Hey guys, thanks for tuning in to another video on InRangeTV. Today we have an opportunity to interview Nathan from Faxon. Faxon is a manufacturer of AR parts and barrels in particular, and we thought we'd pick his brain today about barrel making specifically, or barrels specifically.
And I would say Faxon, well, first of all, Nathan, we spoke to you at SHOT Show, and without giving away too much, we're working on some cool projects with you guys, and you have some really unique stuff coming to the market that really separates Faxon from some of the other guys in the industry, I would say.
Definitely.
And one of them that comes to mind is your barrels. You have some really interesting profiles. You have lightweight barrels, pencil barrels, heavy barrels, the whole 9 yards. And so we were talking to HMG in one of the long Q&As, and barrels came up, and one of the discussions brought up chrome lining. Right. And someone said to me, well, what about this nitride, blah, 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 blah. And I'm like, And Nathan, you said, well, let me give you guys a real, let's say, what's the word? Primer, that's the word, on barrel manufacturing and what's going on with the modern state of barrel manufacturing. I have to admit, I shoot guns a lot. I know what barrels are. I know what rifling is. I know what rifling twists are and all that. But when it comes to coatings and treatings and chrome lining and all that, wow, we're looking to you.
All right. Well, there's definitely a lot of questions that I'm sure you guys will ask. So I'll just tackle the first one that you brought up, which is, say, nitride versus chrome lining. And that's one we get on a very regular basis, especially as everyone goes, well, chrome or nitride's cheaper, therefore it must be worse. No, like many things that are modern technologies and modern improvements, you're able to reduce cost while simultaneously increasing capability, at the same time. So it's really interesting, though. We make both. We make chrome-lined barrels. We make nitrided barrels. I make unlined barrels. I mean, the customer is always right. But our perspective is that there's definitely a need for both of them in the modern world. So it really goes back to exactly what is nitride and what is chrome lining. Right? Chrome lining, as the name implies, is truly a lining of a separate material into the bore of a barrel. So you are adding a material to the bore. Nitrocarburization, or nitride, melanite, isonite, QPQ, whichever term you want to use, they're all roughly the same thing, is a treatment to the base steel, not a lining that's added to it. So by being a treatment, you've got a couple of advantages over chrome. Number one is you have a better potential for accuracy, all things being equal. So let's say if I took two barrels that I manufactured today, literally right next to one another, and I send one to nitride and one to chrome, the one that goes through nitride is going to be treated in the base bore as it was directly machined by us at the factory. Chrome lining is going to be an electrolytic process. Typically, an anode is run perfectly down through the middle of a barrel. It's immersed in a chrome-filled solution, and then the anode is electrified, and the chrome then adheres to the bore. While the chrome guys are very, very good at it, especially after 100 plus years of doing it, it still adds the potential for adding additional imperfections to the bore. Therefore, the accuracy, all things again being equal, will not be 100% of nitride, but most of the time it's really, really dang close. But again, for a guy who's trying to go for, the best accuracy that I can possibly buy, nitride's going to give you that slight advantage.
So on that note, I'm not trying to stop you, but that you gave me some ideas. So I used to shoot a lot of NRA high power, Camp Perry, all that stuff, and we would avoid chrome lined barrels entirely. We normally had straight up stainless barrels, and we accepted the fact that those barrels would wear out sooner because it wasn't as hard a surface for the high velocity projectiles we're using. But we accepted that, and after a couple thousand rounds, we take the barrel off and throw them away. However, so chrome lining has a pretty long history, right? I mean, most people think the Japanese were the first ones to really do it, but that's not true.
I think there were some people first, but militarily, chrome lining has been historically, you do it because you've got corrosive primed ammunition, and the chrome lining is far more resistant to corrosion than a plain steel barrel.
So the Japanese are well renowned for being the first ones to really issue them in large numbers.
Yeah, the Type 99 Arasakas.
So what you were saying, just to make it simplified, to make sure I got this right for us and for myself and the audience. So since you use essentially a process to bind chrome to an already manufactured barrel, that process can cause maybe thickness deviations or things in the barrel that is the chrome lining. And while that increases the hardness and the durability and the corrosion resistance, it can impair accuracy. Now, my experience with chrome lined barrels is the difference between chrome and not chrome lined is pretty minimal, but it's still a real thing. And your nitride coating is different because that process that gets the coating on there is more consistent, and therefore the thickness and all that goes on makes it less likely to have a problem.
An excellent summation. The only piece I'd say is slightly different is nitride is not a lining at all. It's truly just treating the bore as it existed directly from the manufacturer. So if I make it perfect, then it's going to be perfect when somebody adds nitride to it. All you're then going to be doing is adding the chemical properties that nitride puts into the steel for its benefit.
Almost like a heat treat rather than anything else.
Very similar. So from a chemical perspective, what it's really doing is you're imbuing nitrogen into the steel, and that does a couple of things. It increases corrosion resistance markedly. In most cases, a QPQ process, which is not exactly the same as QP or just Q, but a full-blown QPQ process will actually drastically increase resistance to corrosion compared to chrome lining. So it's an order of magnitude difference.
I don't know what Q, QP, or QPQ are.
And the nice part is about nitride versus chrome lining. Chrome lining only does the inside of a bore in a chamber, and then you have to do something else to the outside of the barrel to maintain corrosion-resistant properties. In most cases, it's parkerization, a manganese phosphate, something very, very similar to that. Manganese phosphate requires oil. Nitrocarburization does not. So especially in maritime environments, nitride has a huge advantage over chrome simply for that corrosion resistance. And to expand it a little bit further, you can also nitride stainless. Trying to chrome line stainless is very difficult. So for what you're doing for like NRA high power, you're actually able to nitrocarburize barrels and get significantly increased life out of them compared to a unlined or uncoated barrel.
When did that process really come to the market? Because when I was shooting high power heavily, it wasn't that long ago, and I don't remember that really being on the radar. So when did this become a reality?
So it's in the absolute precision world, it's starting to gain some steam. As with many things in the firearms industry, historical knowledge and beliefs that people have, really hold on quite a while and perpetuate. It takes a lot of testing and a lot of data for people to move off of that. And, that's a good thing. You're talking about a gun. So, but what you really see it now is it really, you could say, hit stride in the late 1980s, and I'll point to Glock as being the prime example. They were the first to really use nitrocarburization in a firearm, and it was mainstream. So from there, it's expanded slowly. You now have it to the point that nitride is in military rifles. It's in military weapons. Classic example is going to be the Remington XM25, I believe that's what it is. That precision rifle system is a nitride-coated barrel. You've got now the SIG's XM17, assuming Glock doesn't win the competition, but either one of those are going to be nitrided barrels in something. Where you don't see it is in machine guns, and there's a very good reason for that. And a lot of that has to do with how the barrels handle heat. So when you nitride a barrel, you're still having the same base steel. In most cases, it's a carbon steel, or in some cases, stainless as well. But you're not changing the chemical properties of how that barrel really deals with heat. So once it gets to the point that that barrel would anneal, the rifling starts to fade. Now, I'll put a big asterisk next to that. For a barrel to get that hot, it takes consistent, fully automatic fire. So a civilian, somebody even with a 3-gun and Jerry Michalak with a 100-round drum, still really can't get a barrel hot enough that they're going to see this difference. But in a machine gun, where you're having consistent high temperatures, high pressures, etc., chrome does have an advantage over nitride, in that it's able to handle the heat better without the rifling degrading. So when you look at, what you could say, military weapons, I personally see you're going to see nitride a heck of a lot more, especially in your precision work and some of your semi-auto or light-duty weapons. And then you're going to see chrome being reserved for where accuracy isn't necessarily important. Volume of fire is by far more important.
The ACR, when it came out, was not chrome lined, and everyone had a conniption fit that it wasn't a chrome lined barrel, therefore an inferior rifle. But you're saying that they were actually the first ones to adopt this in a commercial way, thinking that this was the rifle of the future, and this process was the barrel manufacturing that should be for the future. So there really is this perception of, it must be chrome lined, but maybe that wasn't a really correct assumption from the consumer base?
I would fully agree with that. And we talked about that differently. Bushmaster, it's the advanced rifle. If I put nitride in it, people are going to assume it's advanced. And entrenched thought really backfired against Bushmaster on that, and I believe unfairly. But it's also interesting, and we never had a chance to really talk about it previously, is Nitride is used in that rifle extensively. You have it on almost every single steel part inside that gun is nitrocarburized. So the gas block is, the piston is, the bolt carrier group is, the bolt carrier guide rod is. So you have a consistency of material. So you're going to talk about, when you go into weapons design, part 3 probably, you talk about being able to have, consistent coatings and consistent wear patterns across all of your parts, not just, oh my gosh, in the AR-15, we understand the aluminum is going to be sacrificed at the altar of the steel bolt carrier.
So the ACR being an early, well, not early in that this process has been around, but being an early adopter to the commercial market with such a process, got burned a little bit because they went against what was the common herd knowledge, and we all know common herd knowledge is always right.
Always, without fail.
That's very interesting. I wanted to grab that because I admit I remember hearing that outrage and not understanding that. And so that puts an interesting bend on the fact that they were actually doing something forward-leaning, and sometimes you get hurt doing that.
Yep. And to a testament to what they did, our ARAC today uses a lot of what they did in terms of some of the basis of our design. We use steel-on-steel contact, all nitride components on our gas block, bolt carrier group, etc., for that same consistency, because the coating has more applications outside of treatment has more applications outside of just the barrel.
Because two very hard surfaces running upon one another, for one, don't wear very quickly, obviously, and for lack of a better word, they're kind of instantly, there's a lot of lubrosity or whatever the term is. They're pretty slick. They slide against each other without a lot of friction as a result, and therefore the need for more lubricants, etc., is diminished.
That's exactly it. Matter of fact, I've never shot an ARAC with lubricants in it. And you see now, nitride is used heavily on AR-15 bolt carrier groups. It's all over the place, and that's for the exact reasons that you mentioned. It doesn't wear like manganese phosphate does, which you're going to see bright steel rails on a manganese phosphate carrier. When that happens, you've lost your coating and your corrosion protection. In a nitrided component, you've lost the black oxide outer layer, but the base nitrided and treated steel is still there, still standing up against the elements.
Interesting. Very interesting.
Actually, as a follow-up question, that's really cool. What is it, or is this related in any way to Stellite? Something I've seen a lot for like old M2 50 caliber barrels.
Yep. And we are intimately familiar with that. We've manufactured barrels that would eventually take Stellite linings, which is an incredibly fun, precise, very tight tolerances. Because what typically you're doing is you're taking a piece of Stellite, which is a high nickel content alloy, and high nickel content alloys, so that'd be Stellite, Inconels, all of those similar veins of alloys are excellent with extremely high temperature. But as any suppressor guy will tell you, machining them is a royal pain in the arse. And
trade-off, isn't there?
Yep. So what typically happens is you'll create a Stellite liner that will take the first 5 to 7 inches of a barrel, which is where you're the hottest, so that you're able to get longevity out of it during that course of fire versus the base steel barrel. So it's a liner that's typically pressed in. You don't machine the whole barrel out of it because it's incredibly hard to machine. It's incredibly hard to keep accurate. And just from a mechanical standpoint, lining up a Stellite bore inside an already machined piece of steel that you're drilling into is very, very difficult.
So do you already have the rifling cut in the barrel when the Stellite liner goes in, and you have to actually align the rifling lanes and grooves?
Depends on the process, but that's one way to do it.
Wow.
Wow, yeah, that does seem like a challenge. We stepped over your one question. I want to leave that. You said Q, QPQ, QZR, KFJ. What else? What is all that? That sounds like math stuff, even though it isn't. But what is that exactly?
So there's different ways to nitrocarburize a piece of steel. You've got gaseous nitrocarburization, which is what actually Glock typically uses. Slightly different finish, slightly different way that it tempers the material, hardens the material, but the practical effect is largely the same. The most common way that you see barrels nitrocarburized is using a salt bath. So it literally is a roughly 1100 degree batch of molten table salt. Would be a good way to describe it. And you're dipping your barrel into that for a set amount of time for the nitrogen to imbue into the steel, and then you pull it out. So there are different processes to do that. The Q, P, and Q stands for quench, polish, and quench. So basically, are you dipping it once? What kind of processing are you doing it? And are you dipping it a second time? And how is that being taken care of? And each one of those, and each person who does nitrocarburization does it slightly differently. For example, melanite is technically different from isonite, which is technically different from QPQ, which is kind of the generic term, but they're all within a couple percentage points of similarity of one another.
When you mentioned, I'm sorry, one second. When you mentioned that process, that reminded me of something from the Old West. The old firearms, when they would case harden steel to increase the hardness of the exterior of the metal, they would use ground up bone, superheat the metal, put it in there, and the carbon would come out of the bone and into the metal, and you see this mottled surface. But the entire purpose was to harden the exterior part of the steel. If you were to cut through that case hardening, the steel on the inside soft, right, but the exterior of it is very hard.
That's actually exactly what I was.
Oh, I'm sorry. Perfect. Okay.
I was going to say it's very similar because what you're doing with case hardening is adding carbon to just the outer layer of the steel because you need the extra carbon in order to harden it.
Yep.
And what you're doing is adding nitrogen to get different properties. And it literally is when you heat the steel that much, nitrogen molecules can basically get sucked into the steel and mix their way into the alloy.
They migrate into the molecular structure.
Yeah.
Right. Now, with case hardening, is it only a portion of the steel, or does it make it all the way through?
It is just a portion. And in terms of barrel manufacturing, we want that, especially because the the part that's nitrocarburized is very, very hard. Typically on a Rockwell scale, it'd be somewhere between 65 to 75. Again, I'm talking general terms. That's very hard. And the problem is when you make steel that hard, it also gets very brittle. So its ability to contain pressure, exactly, Ian, catastrophic booms and bad things happen. So what you try to do is you want to have a base piece of steel at the hardness that you want your barrel at, and then you'll nitrocarburize your exterior surface for that abrasion resistance, the increased hardness, increased corrosion resistance. But by having the through hardness exactly where you want it, you then have the elasticity and pressure containment portions of the steel that you need for a barrel.
This is very interesting because now that analogy really works for me because I'm a big fan of the 1800s guns, and now I think of this as modern case hardening for barrels. That's how it.
Yeah,
that's how
good way to describe it.
Yeah. Wow, that's fascinating.
Yeah.
So
definitely.
Yeah. So what you're saying is chrome lining still has a purpose for very high temperature applications with machine guns or belt feds, but for the average or any other purpose, let's say even an M4 carbine, there's probably not a reason to do anything but nitride because nitride makes sense. It's not going to be a belt fed, and God forbid you're dumping all 6 of your magazines at once, right? So
that's a good way to describe it. The military's gone back and forth. They've looked at nitride heavily. As we talked about, they've adopted it in a few weapon systems. The big kind of kink that was thrown into the wrench was M855A1. That's a particularly hot and nasty round. So the nitride was set aside in favor of chrome for that reason and for that specific round. But anybody using SAMI specification or even standard NATO specification ammo, I tell you, go nitride any day of the week, especially considering it's anywhere from $20 to $50 less expensive than chrome.
Nice. So does this also mean that there are times where you would not want to use nitride for very high velocity rounds? Like, is that what you're saying? So like if you're like a wildcat shooting something that's like a 22-250 and you're pushing bullets at 4,500, 5,000 feet per second, whatever, is this a place where this doesn't? I know exactly. I'm just throwing that out there. It may be a little crazy, but if you're throwing stuff really high velocity projectiles, and I realize that's a really extreme example, but is this a place where nitride is not appropriate then?
No, it's even more appropriate for that because you're going to have the increased abrasion resistance compared to the base piece of steel. So you'll actually have a barrel burning caliber burn barrels less. Forgive me, when I said hot, I meant in terms of pressure. Basically, M855A1 is a proof round. So, and it's, again, relative to the outer diameter of the base bullet. What is the pressure behind it? There's a lot of things that go into the mechanics of what lining you're going to want to choose. In the case of M855A1, chrome is probably the better choice. But again, for anybody shooting 3-gun, carbines, I'd take nitride any day of the week.
Go ahead. So what about stainless versus non-stainless barrels? What are the pros and cons? Where is each one appropriate?
So I'd say the difference today is not as pronounced as it was 20, 30, 40, 50, 80 years ago. And a lot of that's just due to the quality of manufacture of the components has reduced the difference between the two significantly. So what typically happens is, and I guess let me step back for a second. Interesting point of fact for anybody listening, stainless steel that's used in a rifle barrel, So one that's a 400 series stainless is not actually rust proof like 300 series stainless that everyone's used to with kitchen pots and pans and everything. It just has the added chrome for machining purposes. So stainless is easier to machine and easier to cut than the base 4130, 4140, and 4150 carbon steels that are used in most military and conventional barrels. So what that means is the definition and the consistency of the cut in a stainless barrel is going to be better than one in a carbon steel barrel, all things being equal. Okay. So when you pull a button, the rifling has a much sharper angle to the corner at the transition, or it's going to be more consistent as it goes down the bore. Because out of anything for accuracy, consistency is most important, not perfection.
Right.
So the stainless barrel will be slightly more consistent than the carbon steel barrel. But again, the changes and the differences these days it's shrinking rapidly, especially with the way buttons and other things are now precision ground, etc.
So when you say button, what you're talking about is a cutting tool that actually you like use a long drill and drill the center of the barrel out, and then you have a button with the rifling pattern basically on it as cutting teeth, and you drag that through the barrel, and that cuts the grooves into the barrel, right?
Yes and no. So the way you described formally would be considered a broach cut style of rifling, and there's typically four styles of rifling that exist today. You have forged, so that includes cold hammer forge, rotary forging, whichever method you're using, but you're going to impress rifling down onto a tool. Okay. You're going to have cut rifling, which is broken into the two types of single point cut. So that's one cutter being dragged down through the barrel, taking a minuscule amount of material out, reset, cut that same piece again, rotate to do all of your lands and your grooves. From that, you also have broach cut, which is like single point, but you use one tool to do all the cuts at once. Okay. And then finally, you have button, which is instead of cutting, you're actually going to press into the steel the shape of the rifling itself.
Okay. That doesn't seem like it would be the most precise way to do it. But maybe I just
Interestingly, it absolutely can. And a lot of that goes to the progress of modern materials. So a gun barrel quality piece of steel today has far more consistency than a gun barrel quality piece of steel in, say, World War II or even back into World War I. So when you press into rifling like that, it's the consistency of the material and how it springs back and how it interacts with that tool that's going to determine the accuracy of that barrel. So, for example, Faxon is primarily a button rifling house. So I can speak with a little bit of authority towards button. There's, of course, many, many things out there. But we're able to create, sub-minute angle barrels easily using buttons where you wouldn't have been able to do that 20, 30, 40, 50 years ago, or you can. It was just much more difficult than it is today.
Interesting. Okay. And what would be the best? Why would one want a hammer forged barrel today? I've seen hammer forged barrels being made, which is really cool. And just the concept that you have like the reverse image of the rifling, and you stick that down the bore, and then you just literally squeeze the barrel onto it.
I'm glad you said that because I wasn't understanding that fully. So you literally put a piece down what is going to be your barrel blank, and you smash the barrel around that piece, which then turns into rifled barrel.
Yeah. And then you pull the blank out of the middle.
That must be a lot of pressure.
Yeah, what I saw was they actually had a pair of giant carbide hammers, and they hit it this way and then hit it this way, and work their way up and down the barrel.
So you're striking that hammer, striking it, and forcing the steel to conform to what's inside of it.
Yeah.
Wow. So, what is the advantage to that versus button? Is there one?
There is in certain circumstances. So I will disclaim to anybody watching and listening, Faxon does not make cold hammer forged barrels. So I'm not going to, I may have a slight tinge to what I say, I'm going to try and not to the maximum extent possible. So cold hammer forging, which is the most common, that's what everyone refers to, Daniel Defense, FN, etc. Basically, you're doing exactly that. You're smashing a base blank or a gun-drilled and gun-reamed blank onto a mandrel to shape in the rifling. And that can have substantial advantages in terms of work hardening the piece of steel while you're doing it. If you have good steel and a good mandrel, you're able to create very pristine rifling through it. And again, it's consistent because it's all the exact same mandrel at the same point in time. The disadvantage to that is it puts a lot of radial stress into the barrel that cannot be fully stress relieved post-rifling. And oftentimes, if a barrel's thick, that's not a big deal at all. But if you're trying to create a really thin barrel, having residual stress in it is what's actually going to cause, as people always say, oh my God, my group walked. Well, what's happening is a barrel is getting hot, and that barrel is actually starting to stress relieve itself, and basically it's deflecting your muzzle. Exactly. Carl, you've got it right, nail on the head. So you can fully stress relieve button rifling. You can fully stress relieve cold hammer forged. It's very difficult to do so, but you can. And for like single point cut and broach cut, there's no stress involved because you cut the material out of it. You didn't form it by pressing in one way or the other.
Okay. It sounds like the hammer forging might have been an ideal system for the earlier material inconsistencies that you were talking about.
Yeah, absolutely. Because you always have, and you're getting into the microscopic portions of steel, you have seams in material. And, these are very tiny. The only way you can really find that is you always hear everyone make a big deal out of MPI, magnetic particle inspection and proof testing. That's what allows you to see seams in material that you could not see with your eyeball. And if a seam's too big or too long, that's going to cause an inability to maintain pressure because the steel's not binding to itself in the radial fashion, and therefore catastrophic boom. Now, again, that goes to modern metals manufacturing has largely removed all of those issues relating to gun barrel quality steel. Now, it still happens. For example, Faxon's manufactured hundreds of thousands of barrels. I've seen one barrel fail an MPI inspection because of a seam, and it was one that was glaringly obvious. So you do always have some inconsistencies. I mean, nothing's perfect, right? Quality is a game. You're just trying to win.
Yep. It's all statistics.
So, yep. Eventually, something's going to go wrong because, I don't know, somebody sneezed in Florida that day, and therefore the steel didn't.
Sure.
It absolutely happens. So MPI allows you to find that, and now I'm getting off track of what the question was.
The question was that the advantages of hammer forging are magnified with lower quality steel.
Yes, that is absolutely the case. With good quality steel, it just makes it even better, too. So it's up to somebody to weigh the benefits of cold hammer forging versus button rifling versus cut, depending on what they're trying to do. Cold hammer forging, as you guys have covered, was invented by the Germans in World War II because they needed to make barrels faster. Because the original methodology, which is what the U.S. used, which was primarily cut, was really time intensive. And it's actually interesting. Most of the cut rifling machines that are used today are the Pratt & Whitney machines manufactured for World War II in Korea. Okay. And those are machines that go for $1 million+ anytime they go onto the open market. It's incredible. It tells you, one, how good Pratt & Whitney made stuff 50 years ago. So.
Yeah, no kidding.
That said, we did not discuss what that is, and it should be fairly obvious, but you've got a barrel blank, and you use a cutting device to remove material where the rifling and lands and grooves should be.
Correct. And that's got an advantage of you don't put any stress into the steel at all. Especially for single point cut, you're going to have the exact same shape, cutting the exact same thing at the exact same spot every time, assuming you've got a good machine that can maintain that consistency. Broach has a advantage in terms of time because instead of having, say, 80 passes, 100 passes, God knows how many passes through a piece of steel, you pass once. But it all basically boils down to whether it's cold hammer forge, button, single point cut, or broach, it's the quality of the tool and the quality of the machine that's going to determine the quality of your rifling. For example, a bad mandrel and cold hammer forging, you're going to work harden it on into something that's not consistent. If a broach has teeth that break, guess what? You're going to have a land that's going to have a problem. In single point cut, if it dulls, you're going to have inconsistent edges on the edge of your rifling. There's always a challenge everywhere in barrel manufacturing, so it's going to be up to your follow-on QC processes to monitor the manufacturing process and make sure that you're doing good parts.
Actually, I was going to ask you about this. With a cut barrel, the quality is going to degrade as the tool dulls, so you have to replace it on a reasonable schedule. Is there an equivalent for a button rifle barrel? Does that tool wear over time, or what happens to it?
It absolutely does. So most buttons now are tungsten carbide. They're precision ground into an exact shape. Button's nice because you can grind radially, so you can maintain outer diameters very consistently. It's a nice way to be able to create a tool. And you're going to typically coat them with titanium nitride or something similar, but eventually that coating is going to wear because you are putting incredible pressure on it as you pull it through a piece of steel. And even a 1-inch diameter piece of steel is putting tens of thousands of PSI pressure onto this as you're pulling it through. So you do have to monitor and replace it every time.
Okay.
You know, it's interesting. So when you were talking about cutting, one thing that popped in my mind is that also the quality and the consistency of the machine that's pushing through the cut could matter. But at the same time, there has been times, and maybe you'd like to talk about this, in which that's intentional. I was reading that book about the Mauser development during the war, and they were intentionally changing the rifle twist speed rate down the barrel to reduce the wear with some of their aircraft barrels.
Right, progressive
twisting. That's exactly right. So at that point, you'd be cutting, and you'd accelerate the cut or decelerate the cut to change the twist rate somewhere in the barrel. Is that still applicable, and do we still do that?
Yes, we do. It's a typically more quality-intensive, time-intensive manufacturing process. So unless that's needed for a given application, you don't see it very often anymore. But you've got similar things. You've got squeeze bores, where it goes from a larger diameter at the rear to a smaller diameter up front. So you're going to get, in theory, more velocity, more consistent engraving of rifling, etc. But a lot of that's due to when tools and rifling wasn't exactly as good as it was today. And you look at what was considered a precision sniper rifle, 2 to 3 minute of angle in 1917, and if you're any more than a half minute of angle today, a sniper is going to laugh you out of the competition. So you have differences in times and changes in manufacturing methods that, you know, make something interesting, but also can make it obsolete-ish depending on what's going on.
Obviously, this conversation could go on forever because in that book about the Mauser development in those memoirs, he talked about both of those things, essentially progressive twist rifling, as well as smashing down a larger diameter going to a smaller diameter. It increased the velocity of the cartridges being fired out of the aircraft machine guns, and also increased the lifespan. So they thought this was a miracle because they increased velocity and lifespan out of the same barrel. So there's all these little tricks you can do, which is very interesting.
Yeah.
And you're also right about sniper rifles. Back in World War I and World War II, 3 MOA was considered acceptable.
Right.
3 MOA today, people go, why is that gun broken? Right? I mean, that's an AK by people's standards now. So perception of what accuracy requirements are have changed.
Absolutely. Yeah. There's more manufacturing processes.
If a new gun comes out into the market and it shoots less than a minute of angle, holy smokes. And it's an amazing testament to how good rifling and barrel manufacturing has become.
Well, I honestly think we could do more of these. This is there's so much that could be done here in terms of metallurgy, rifle manufacturing, barrel manufacturing.
Yeah.
I don't know if you're interested, Nathan. We maybe could do another one in the future. We'll do a part 2 or something like that.
Sure, we'd love to.
I don't want to saturate the viewer with too much data because, frankly, my head's spinning a little bit. There's a lot going on here.
Yeah, this has been really cool.
Yeah. So anything you want to bring up about anything with Faxon or going on with Faxon to our viewers right now since you have the chance? Or I know we have projects coming up where we're going to talk about some stuff from Faxon in the future, but this is an opportunity here.
I'd say the interesting part, and this might be a piece for topic 2, is a focus on barrel profiles, the implication of stress relief into what allows somebody to do, say, pencil thin profiles today versus, all right, when pencils first came out, Colt did it, everyone hated it. Oh my God, the accuracy was terrible. The groups open up or it walks. That's not the case today. That is absolutely not the case today. And so one of the things that really put us on the map from a retail perspective, we do thousands of barrels for OEMs as well, was our pencil and our skinny profile barrels that show amazing performance using today's modern methodology versus the older stuff.
And that's one of the reasons we started talking to you is because you're one of the only, I don't know about the only, but the only one I could find that was making what you would call a pencil profile barrel, and we were interested in that for what we're doing. So Faxon was the obvious choice. I don't know of anyone else doing that. So, and I think that there's a lot of merit to that. I would say that, honestly, even the M16 and the M16A1 with its original pencil barrels, I don't think the accuracy is that bad. In fact, I've shot those guns wonderfully well. When they get hot, they start to string, but unless you really abuse them, those rifles work. So I think those pencil barrels work. Now, we're going a little longer here, but those pencil barrels for the original M16 and M16A1, were those cut rifling? How do they do those? Do you know?
The mil spec for the M16 is actually button rifled.
Okay. So I thought you said button rifling on a pencil barrel wasn't great.
No, button rifling without stress relief is bad. So the key is the metallurgical process post-rifling to remove the stress that would allow you to machine it to pencil thin without having your bore walk.
And that's why you at Faxon can do that now with a pencil barrel better than they did in 1967.
Yep, better understanding of stress relief and manufacturing processes. Chrome lines, again, far better today. You hear chrome line Colt barrels. minute of angle consistently. Chrome's gotten a lot better too, especially as the bores have gotten better that are manufactured.
Okay. I think definitely we should have a part 2 where we talk about all sorts of different things regarding barrel profile.
I agree. If you're up for it, Nathan, we're down for it. We'll schedule it. We'll have a part 2 to this because there's a lot to talk about here.
Sounds great, guys. We look forward to it.
What I do want to tell our viewers to do is absolutely go to the Faxon site and check out their products. They have some very unique offerings coming to the market that I think really differentiate you from some of the other part manufacturers in the industry, and that's why we're really interested in what you're doing. So
yeah.
And I wanted to thank you for reaching out to take your time today to spend with us just talking about this stuff because it's a learning experience for me. Maybe not as much for you, but a lot of that was stuff I didn't.
I learned a good deal today. This has been really cool.
So thank you, Nathan, for that, and hopefully our viewers feel the same.
Thanks, guys.
Appreciate it. We'll talk to you soon.